Code Ready Workspaces, leveling up your job and development IDE for the remote first world. So just quickly, we have a lot of ground cover. My name is Dean Peterson. I work for Red Hat. It's an enterprise open source software company. So all the technology that I'm talking about today is open source and comes from Red Hat. So if you've been around as long as I have, Red Hat should probably be a household name. It's also part of IBM now. And so just a little bit more about myself. I've been doing writing software for 20 years. A lot of it's Java. We're going to be talking about Java today. And, I also, I have a computer science degree and a master's in software engineering from UW La Crosse, as well as I am the creator of abecorn.com. So I don't know if anybody on here has math traded board games, but I'm hoping eventually everyone or a lot of people have done that. So abecorn.com is a math trading site, so I created that as well. So let's just jump right in. We do have to do a few slides just so we know what we're talking about today. So kind of the progression of Java, and how applications are being written today, right? We're trying to move away from the monolith, and containers are a very big thing. Kubernetes is the winner in that space, and we want to have applications and containers that run really well and have languages that run really well inside containers. So we've got a lot of good technology that's come out of the Java world, and we don't want that to go away. So we're going to have, we have a Quarkus now, which is a technology that makes it very fast to run containers and spin up Java in that type of space, and can be used in a serverless type of framework. All right. So as I said, there's a need for a new Java stack for cloud native and serverless. And so that's Quarkus, supersonic, subatomic Java. We're going to be doing a demo of a lot of this stuff here in just a minute. So one of the primary benefits of it is you just get a very small footprint. We compile, it's compiled down to the native machine language level. And when you deploy that, it's going to take just nanoseconds to spin up, as opposed to, Java is made for that server to consume as many resources as possible and remain stable for a long time. That doesn't really play well in the container space. So Quarkus does. It's much smaller, much faster to spin up. So there's developer joy there, and you can, unlike regular Java, you spin up and use something like Code Ready Workspaces. You can actually change your code and see your code change, just like with a Node.js type environment. And that's very important for enjoying what you do when writing code. It combines both imperative and reactive. So there's a number of first class citizens that you can bring in other frameworks like Vertex and its event streaming bus. And you can kind of mix that imperative and reactive type programming. And so you've got an extensive extension library that can make your code compatible with all of these various types of things. All right, so let's quickly get through. So the other thing that I'm going to be showing you today that makes remote work a lot easier, and then much easier for you to write applications that are ready for the container native, cloud native world, is something called Code Ready Workspaces. It's an IDE that's browser based, and a lot of times when you have consultants coming in doing work for you, so you want to get people up and running as fast as possible. You don't want to have to spend a day or more trying to get workspaces to be the same across the board. So we've in this space, you can just get an IDE that is in your browser. You can access it anywhere, and it will improve your time for coding by 39%. So the traditional laptop approach, right? You've got all of these different components that are hard to share: the terminal, the operating system, the web server, the database. So if Code Ready Workspaces runs inside a Kubernetes environment called OpenShift, and that makes it so that you're inside a platform and you're able to take advantage of all the things that the platform provides. So the Code Ready Workspaces method is that everything is managed in this containerized workspace environment. And I want to get to the demo so that you can kind of see what I'm talking about. So Code Ready Workspaces is, it's going to accelerate your projects. It's going to remove those inconsistencies. And then it's going to also secure your code so that you're not having to let your remote workers bring that code home on a laptop. They can access it from anywhere and not have to necessarily, VPN in and access a remote operating system. So it's going to be a lot faster, a lot more lightweight, and integrated with that platform, Kubernetes. So today, the demo, ultimately, we're going to do a few things really quickly, and then we're going to eventually get to this end demo, which is going to be streaming using an actual Kafka topic. So we're going to be generating a bunch of names with a, like a honorific, and it's going to be coming up kind of in this animated fashion on the screen, but it's going to be generating names, putting into a Kafka topic. We're going to use Quarkus to actually pull that those names out of Kafka without a lot of work, and then stream that to the screen. All right, let's get going. All right, so the first thing I want to do here is just show, there's a lot of stacks just out of the box. Any good IDE is going to have some, get started quick type of environments. These are all backed by containers. So when you run your workspace, you're actually running inside a container. And then you can actually take that same container that your workspace is backed by, push that out into OpenShift or Kubernetes, and then be in production in record time. So this, and you can create your own customized workspaces as well. So I just wanted to show I've got 3 running here, and kind of the primary driver behind these types of things. You could just drop in a dev file that looks like this, that will kind of set you up, tell you which image you want to use, and then you're kind of off to the races. You start it up, and then you're good to go. So I'm going to switch to this Quarkus halfway. I've got various workspaces in a certain state in each one that helps us with the demo. So the first thing that I want to do is just get some feel for the basics as we move around. So the basics here is we're just going to we're going to show an application running. So I'm going to start up my, live coding. So we can start with live coding. So right now, if I start that up and I do a curl for the application that's running, there are some extensions that you can add for things like health checks. And those health checks will put endpoints in place that will allow something like Kubernetes to know if your code is live and running and healthy. So we've got a couple, out of the box, it'll create an endpoint for you. I've got a couple that I've also added. So I'm just going to create a new terminal here. And when you see that I'm running a command against localhost, that isn't a local host like on your regular laptop destination. That's a local host. We're logged in with this terminal to the command, to a container. So the container is running everything. It's not actually a local host. So, but we'll show pushing this out to OpenShift and in Kubernetes in just a second. But if I run this command here, we've got a liveness check that just shows a couple of things. Let's go ahead and add a new file, and then we're going to call that database connection health check.java. We're just going to throw some code in there. All right. All right, we didn't notice how I didn't even have to save. It just automatically saves, so we don't have that control, S all the time. And we're just going to run that same command again. I didn't do anything different. So it's just, I didn't restart a server or anything. And now you'll see that in here, there's going to be another health check that shows if the, that the database connection health check is up. So we've got it there. Whereas opposed before when we ran it, we didn't have this database connection health check. So that's what this thing is putting out. So it's going to say database connection health check. So we didn't restart a server. We didn't do anything. It was just there and ready. So that's a very nice thing for development productivity. All right. So the next thing that I want to talk a little bit more about are the extensions and that extension framework. So you can, with Maven commands, so it's, if you're familiar with Java application development, you're familiar with Maven. So you can run a Maven command to basically just add a dependency, but that dependency is kind of special. What it does is it's a build time augmentation and a runtime. So it does build time augmentation and it changes things that for the runtime container. So it's basically responsible for all this metadata processing, such as reading annotations, XML descriptors, etc. So the output of this augmentation phase is recorded bytecode, which is responsible for directly instantiating the relevant runtime services. So that makes it, you do so much more at build time, and that new dependency that you bring in is actually augmenting your code, outputting and modifying the bytecode so that you can do some pretty significant things. And then you do that at build time, especially if you're doing a native type of compilation. And then that's what gets you that very quick time to start up and low memory footprint. All right. So, just if you wanted to check out the, some of the extensions, you can go to code.quarkus.io. We've got extensions for, a lot of different things, REST Easy, Spring, so that your Quarkus, basically Java code can be compatible with all the other types of Java things that you've been doing for a very long time. But you can turn that into very, very fast container-ready code. And you can run it outside of containers as well, but it shines in things like a serverless type of framework. All right. So the next thing that I want to do is I want to jump to doing something a little bit more sophisticated. There's other components that Quarkus supports. So when you add an extension, so let me bring up. Oh, actually, no, sorry. The next thing that I actually want to do is show the difference. So when you go back really quick here, when we show what we've done with the startup live coding. So in here, you can see that we started in, normally it takes like something like 1 or at least 2 seconds to start up using the OpenJDK version. So you can start up with a regular JVM, that's still faster. Or when you actually start it up with the native Java compilation, then it will start up in sub-milliseconds. And I notice here, because it actually takes a lot of time to build the native app, I did have it built because this is a container. I don't have it currently backed by persistence. My jar file for that went away. So I'm not going to run it, but what I would do is I would run that command, and then you would see that spin up, and then it would be very, much faster to spin up than this. It would be like 0.00 seconds. So just know that that's there. And then we can also deploy this code to OpenShift. And I will start this off. So if we want to, we can come back around to it. So we've got some other things that will show you, show you some of this. So let's actually go to the other workspace now, and we're going to do some things with event-driven development. And we're still going to be working within the IDE and the local container. So eventually what I'm going to be showing you at the end is we're going to take this and move it into OpenShift. And there are commands and tools on the right-hand side to make that easy. All right, so let's do a couple of things right now. Let's start with adding a new extension. So we just come in, we just create a new terminal. And it's as simple as running a Maven command. And for all intents and purposes, what you see in your code, the thing that changes is a dependency added to your POM. So I just added a dependency for Vertex, and Vertex is a reactive framework for reactive style programming. And it gives you things like an event bus that allows you to do messaging inside your actual framework and your application, as opposed to having to go outside for something like Kafka or an AMQ broker. And it lets you do that nice event-driven decoupled type of architecture. So when you make a change to something, you can make that asynchronous and happen in a more reliable way. So if something was down at a certain point in time, that it can happen again without you having to send a new request. All right, so we've added a new extension. So it says adding extension, and then this dependency shows up. This is a dependency that will actually modify and do some special things. You can write your own extensions, and there's a guide for doing that too. And and then you can check out the Quarkus website for that type of information. All right, so what we're going to do is we're going to add to this, and all of this is going to be happening with live coding. So let's go and start our live coding tab. And we're going to go into our source. We're going to go to main. We're going to go to Java, and we're going to go to REST. So we're going to add to our person resource. I'm going to close that. I don't want to open up the browser. I'm just going to uncomment these things here. Without that extension added, this would have caused compilation errors. But I'm just going to bring all of this stuff back. So what I'm going to do here is I'm adding an event bus. There's 3 flavors of this event bus since I've added that extension. I'm using this Axle type of event bus it's good for, it works well with Quarkus and the microprofile implementation that Quarkus implements. And I won't go into what microprofile is. Definitely that's something, if you don't know what it is, look up. So what we're doing here is as we make a request to this post endpoint, what we want to do is actually, as opposed to just going directly to the database and creating a new person given a specific name, we want the event bus to receive a message and then a consumer. So what we don't have in place yet, if I were to run this command, so this curl command right now, we don't have a consumer yet, so it's going to fail. All right. So if I do that, it's going to fail right now. So we got a 500 internal error. And if we went back to our live coding here, it would show us that we don't have a handler for add person. So let's go ahead and add something that can actually consume that message and make that error go away. So I'm going to create something called it's going to be the person service. That is a consumer. All right, let me go ahead and add new file. And notice that I'm not restarting anything. So person Java. Right, what it's doing here is it has an annotation called consume event. We don't have to write a lot of code to make something like this work. And it's going to be listening to the add person stream. All right, let's go ahead and rerun our command now. And all we're doing is posting to the person, giving it the name Joe. And from that point, we should see that we've added this. So we can do another command to curl for that person Joe to see that he's actually in the database now. And he is. All right. So we did all of that without restarting any server. We changed some code. We just added an extension, and now we have some pretty sophisticated ability to do event-driven type of architecture directly within Quarkus without spinning up integration software. Now let's actually take it up a level. What we can do here is let's switch now to our final workspace. Make sure I'm in the right workspace here. All right, let's switch to this guy. And what I would do, I've kind of done the work already to push it, but it's very simple. You would log in to OpenShift, and it has all of the tools built in. So I'm just going to say to do that communication with the OpenShift that this Code Ready Workspace is running in. And now it says you have access to 63 projects. You can go ahead and close that. And if I had a new terminal, so if I open up a new terminal window and I did something like OC get nodes, for instance, you can see all of the machines that are responsible for the Kubernetes cluster that I want to deploy this application to. So before, when we were talking to localhost, that is still running in a container. That's a container that could is still going to be the same container that you can push into a project inside OpenShift, but then that project is going to work well with a container, like a CI/CD pipeline that you could essentially take a running container from development And the difference between running in development and production would simply be moving that container from development to production. It becomes that simple. And then you have access to all these other things, which I'll show in a minute. So if I did like OC project, this live, for instance, we could switch to this project and we do things like OC build. So I've done that with this code here. I've got the code a little a bit further along, and what we're doing is that picture that I showed you a little bit earlier. We've got some code that, if we go and look at the stream section here, we've got a name generator that's going to be generating names to the outgoing stream called generated name. And then we have some resources called application properties that wire everything up that we can look at. And Quarkus is good with different types of profiles. This %prod tells it, okay, this is what's going to be used for prod. So we've got a topic in running an OpenShift. So I'll bring this up. If we were to go and look at, for instance, let me actually switch over to the administrator view. So we're inside OpenShift now, and this is what our Code Ready Workspaces is running inside of. And we have access to all of what this provides. And then we're going to go to, look at projects. So the project that I have this actual application pushed out to is called Quarkus Demo. There's a number of things running in it. One of those being, so if we were to switch back over to developer, we can kind of see a topology map of what's all running. I have a Kafka cluster that I've spun up with an operator that can take the messages that we're generating. So here's our application. Our application is accessible via this URL. And we're going to go /names, for instance. To see the actual application. And then, so if it doesn't start up, we can restart so what we're doing, and we're seeing the end result of what we've deployed is those names over here in this name generator is going out to a stream. It's being connected via the application properties. The converter is converting the names that are being generated and just adding a kind of this honorific to the name. So those messages are going out to Kafka, and we got Kafka up and running by just saying, as a developer, I could come in here, say, all right, I want to get something from the catalog, go to Kafka, and I can spin up a Kafka or a Kafka topic as simple as just a few, just fill out a few things in this form and you're good to go. And now with this code and just pushing out to OpenShift, we can take our code that's running in the container that we were working with in this type of local environment and get it out to an actual namespace in OpenShift, and then have a production level application that we don't have to change anything. It's already a container. It's already packaged up exactly. The developer didn't have to know anything about how to create a container, but then the operations team can create a CI/CD pipeline that simply moves it from one namespace to another, and you're up and running inside production. And then we've just, this is what this application is currently doing, is it's spitting out those names that were being produced and put into Kafka, and we're transforming them and displaying them to the screen here. So we've done a lot of things. This is kind of where the world's going. You kind of have to have a platform like Kubernetes, OpenShift, in order to achieve some of these types of things, rather than get down to that low level and write everything yourself. Really take advantage of the platform to do the things that normally you pretty much had to code or do some other type of like server or application server that no longer does that work. You do it with OpenShift or Kubernetes. All right, so it looks like my time is up. I appreciate everyone joining today, and thank you very much.